So for 12.3, that's really just an extension of 12.1 and 12.2. The first page really is just asking you about what's important from those following equations and the terms. And that's really just utilizing 12.1 and 12.2 knowledge there. So if you're confused, look back to those videos. Number 5, really you just want to prove that these are the same function and graph them. You can really use your important points to help you graph quickly. 6 and 7 are really just an extension of 12.2 to give you another chance to convert between all forms and identify important points to plot. Now 8, 9, 10, and 11, you will be asked to sketch each function without creating an input and output data table. So you want to use the important points based on the function and the form it's given in, and state the domain and range. Now, don't forget about domain and range. Domain and range just simply deal with the possible inputs, and the range deals with the possible outputs. So I'll give you a hint here and help you out. The domain for every single quadratic function is from negative infinity to positive infinity, or you can think of it as all real numbers. The range is going to depend on the maximum or minimum, and if it's a max or min, that will determine whether this will go on to negative infinity or positive infinity. And really you need to know what the graph looks like and what the vertex looks like based on the leading coefficient and the form of vertex form. So let's actually do number 10 together. I'll help you guys out by walking through this one here. My domain, as always, I'm just going to put negative infinity to infinity or all real numbers. This is given in factored form, even though this first parentheses is missing. You can think of it as x plus 0 times x plus 6. And if I want to use the zero product property to find my x-intercepts, I just set each equation equal to 0. First one's already done. The second one would give me negative 6. So that tells me I've got an x-intercept at the origin 0 and then another one at negative 6. So right away, I know those important points. And I can actually distribute to get this to standard form. That would give me x squared plus 6x. Wait, there's no c term. Don't fret, just put plus 0. So if that's 0, that must also be my y-intercept, which makes sense because that's where I'm crossing the y-axis. So if I want to then determine the vertex, I can do a few things. I can complete the square. And in order to complete the square, I need to find out what my C2 term is. And since my leading coefficient A is 1, I can just divide B in half and square it, which would be 3 squared, which is 9. So I've got x squared plus 6x plus 9 and minus 9. And this trinomial will become parentheses x plus 3 squared, a perfect square, minus 9. So that tells me my vertex is going to be at negative 3 comma negative 9. So I go over to negative 3, down to negative 9. That's somewhere down here. Well, that makes sense. Another way you can get your vertex is by using negative b over 2a as my input and the output of f of h, because this will equal h. And negative b would be negative 6 over 2a, which is 1. So that would be negative 3. And that's my h value, which is what we got here. And really, I would need to just plug in negative 3 into my function to get my output, k value. So I have negative 3 parentheses negative 3 plus 6, which is negative 3 times 3, which is negative 9, which is what we got for a k value there. Another way you can think about determining the h value is by finding the midpoint between your x-intercepts. Since my x-intercepts are 0 and negative 6, halfway between there would be negative 3. So, and then I could just go through that process to find f of negative 3 for my output there. That's a little bit more of a just pattern and identifying a trick to help you quickly graph. So now that I have those 3 important points, I know that my lowest point is going to be the minimum down here, negative 3 comma negative 9. My y-intercept and x-intercept are going to be 0, 0. Then I have another x-intercept at negative 6 comma 0. And since this is going to open up, since my lead coefficient is 1, I know that my minimum is going to be negative 9. My maximum is going to extend to infinity. So your range, you want to think of your minimum value and your maximum value set in that notation. So this would look something like this. Passing through negative 6, that is not pretty. Passing through negative 6 down to the vertex of negative 9, and then through your origin of 0, 0.